Welcome to the post-T session. This is a panel discussion, Meshed Intelligence, Multi-Sensor Payloads and Analytical Platforms. The esteemed session moderator has joined us already. She is here with us. I request you all to please kindly take your seats as quickly as possible. A gentle reminder to please do remember to either switch off your cell phones or put them on silent mode. This panel discussion aims to engage in in-depth conversations about military remote sensing, covering topics such as advanced payloads, data fusion, AI integration, edge AI applications, and the groundbreaking concept of multi-payload spacecrafts. Our experts will be unraveling the ELINT intricacies and strategic implications, offering a comprehensive view of the synergies which will be shaping the future landscape of military intelligence and surveillance technologies. So we're all set to start with this panel discussion, which is the post-T session. Please join me in welcoming the esteemed chair and moderator for this session, Dr. P.V. Radhadevi, Director ADRIN-ISRO. A very warm welcome to our esteemed chair. It gives me great pleasure to now invite the esteemed panelists for this session. Please join me in welcoming Mr. Suyash Singh, Chief Executive Officer, Galaxeye Space. We also welcome in our midst Mr. Akash Yalagach, CTO, KaleidEO. Mr. Kannan Kesavapillai, Co-founder and CEO, Augsense Labs. Mr. Gurvinder Chohan, Chief Executive Officer, QSTC Inc. Mr. Damodaran Raman, Director, Deloitte Consulting. I believe we are missing one panelist, but they will be joining us eventually. So with that, I hand it over to the esteemed moderator. It's over to you, ma'am, Dr. P.V. Radhadevi. She's our moderator for this session.
Very good morning and warm welcome to this first session of the panel discussion of the DEFSAT 24 conference. First of all, I would like to thank the organizers for inviting me to moderate this particular session, and it is a very great opportunity to meet all the industry participation and all from this area space. Who is missing? Mr. Suyash Singh has not yet come. Okay, fine. So, I think the topic of today's discussion is the meshed intelligence, multi-sensor payloads and analytical platforms for military applications. So we will have an in-depth discussion in this particular topic. And before going to the esteemed panelists, I'll just introduce myself. I'm Dr. Radhadevi. I am the Director, Advanced Data Processing Research Institute, Hyderabad, which is an organization under Department of Space. And our mandate, ADRIN's mandate, is to develop like software solutions for the effective utilization of satellite data from the satellite SBS programs over the last 34 years, 35 years. It was established in 87. So just to give a briefing, like almost 10 satellites are already available as on today, which are meant for the strategic applications from the Cartosat series, RISAT series, etc. from ISRO. So these data like processing solutions, data exploitation, these are our ADRIN's mandate. Now, like just to set the context of this panel discussion, I will just briefly explain the panel's purpose and format. As I was mentioning, the topic is the intelligent digital mesh, which describes the integration of people, devices, IoT, processes, services and data into a collaborative environment. That is the purpose. So the meshed intelligence or digital intelligence through a single network, everything under single command and control, that should be the focus here of discussion, and hopefully we'll have a detailed in-depth discussion in this particular topic. So what we have to focus is technologies which will increasingly work together in a single network instead of in a compartmentalized way of working. This is what is aimed from this forum discussion in this regard. Meshed network of civilian and military sensors and analytical and upstream and downstream capabilities, including the technologies. This can be the focus of today's discussion. And here I would I would like to give a one mention that it is very interesting to note that this digital mesh with new technologies is complementing or empowering and giving a new dimension to the older technologies and help to exploit technologies in a more innovative way. Like I would like to give one example. Now the Geo AI is a terminology which is coming up very much in a very fast manner, and it is nothing but an amalgamation of GIS and the intelligent technologies like ANML. We know that today so much of data is getting generated in the social media and different forums. Everywhere location is a key. So this GIS technology is complemented by this particular information, and GIS can be used as a platform for showing it in a visualization, 3D visualization, etc. Whereas other way around, AML based techniques when we are using, suppose there is a location for a search component. Today we are aware that entire all the airport region, everything are available in polygon form in the public, means in the open source. So we can use all of them as a search criteria, so that it will be very fast and false alarms will be very less. This is just a small example. That way, older technologies with which we all started our career, like GIS or photogrammetry, all these things are getting complemented and finding new dimensions of applications with the new platforms like AML, quantum and such areas. So now, sorry, my journey in Department of Space, I started in 1989, and at that time we started the realization of satellite. Actually that was the time, 1980s is the time when it was understood internationally also that space can be a viable source of information for the strategic applications, and towards that purpose ADRIN was constituted. And we at that time we were having few civilian satellites as like experimentation, like Cartosat series, IRS-1C, 1D, 1A, 1B, such satellites only, and some ground GI remote sensing as well as geostationary satellites were there. And our design, like at that time, the satellite design and manufacturing benchmarks were totally different from today. We used to realize the realization period, like conceptualization to realization, it used to take almost 2 to 3 years of time. And we were concentrating on big satellites, so that because fuel, stability, all and long life, these were the criteria. Whereas today, it is a paradigm shift in the concept what has happened. We are looking for small and smart satellites with miniaturization, and in all subsystems and in material, everything, and 3D printing type of technologies have emerged at LEO and MEO orbits, and that has become actually this and with multi-sensor capability or launch on demand satellites. All these are the need of the day, and this is what we are going towards also. Now coming to downstream, like data processing, data processing methodologies and all. As I was mentioning, we were adopting the conventional technologies like satellite photogrammetry, GIS, or even image processing in the core, like raw form, that image processing. Such technologies were used for the data processing purpose for all these satellites. And now the technologies like we know that the past decade has witnessed an unprecedented technological advancement in cloud, mobile, IoT, AML, all these different areas. So it has been revolutionized the data processing techniques or methodologies also. Now coming to data exploitation, applications driven from the satellite imagery, these AI-based IT technologies like computer vision, speech and text, deep learning, big data management, edge computing, and analytics, that has opened up or started a fourth, we can tell the fourth industrial revolution which has happened, has really fusing the physical, biological, and the digital worlds today. That is what is today's scenario. So that means there is a paradigm shift in that approach of defining the applications also. Earlier what was happening was, we are having a satellite of 1 meter or 0.5 meter. We will define the applications, what all can be done with that. Now the situation is not like that. This is our application, demand driven. Like this, for this application, what all satellites can be, fusion can be done, and what all different satellites or information, not only satellite imagery, any other public domain codes and open source information, all these things are available, and we can make a like consolidated form of all knowledge imparted into that report or whatever we are making. That is the today's application oriented approach is like we have realized. So what I was telling is the socio-economic impact of in the space, whatever technologies revolution, what has happened in that domain. Now coming to the defense sector. Coming to defense sector, we know that we are in a fluid state of the geopolitical situation. That means neither peace nor war sort of situation everywhere, and so many internal and external conflicts are of varied degrees are there for every country. So this is today's situation, and so we know that conventional war was confined to air, land and sea earlier, but it is not so now. Many other domains have emerged, and cyberspace, that is virtually touching the lives of everyone, and that means soft and hard powers are equally important. So this also necessitates a dual use of technology. Military civil fusion is really has become a need of the day. With all these latest technologies, applications are in the defense sector also. So that is why the boundaries that separate civil and military space assets are getting blurred today. Now this requires a whole of nation approach, and we know that the main today's space ecosystem, there are so many reforms have happened, and ISRO also have opened for the private participation and enabler as being an enabler. for all facilities of ISRO and all. Apart from that, there are many regulatory bodies also formed. So with all these things, this whole of nation approach is what is required today for the this strategic sector, defense sector applications using the technologies from the satellite imagery. Now, ISR capabilities also, this is an essential component of the informationized warfare, where the technologies like advanced spacecraft technologies with multi-sensor payloads, data fusion, information fusion, AI integration, edge computing, quantum computing, all these technologies form the basis for developing the national security also and plan also. So that means information in the real time is the key today for the defense sector. And the purpose of this discussion is to talk on these technologies, part of the digital, which are part of the digital intelligence mesh today, and how it will help for multi-domain warfare by enabling the domains like communication, navigation, ISR, situational awareness, targeting, early warning, search and rescue operations. Ultimately, all types of joint, ELINT, comment, IMINT, all these things has to be strengthened with how it can be strengthened with all these technologies. That is the focus of discussion today. And we all know that the strategic applications demand 6 things. One is high information content. It should be of very high resolution for most of the applications. Then timeliness, frequency of data should be enough to do the operations, and it should be the timeliness should be there, and day and night operation. That means optical and SAR combination of satellites is also a requirement today. And this ready to use products, that is the key. There we don't have time for doing so much of data processing, then all this ready to use product should be there. If it is onboard processing, after the processing only the information product should be downlinked, and that only should be used for the different applications. That is the thing. And another thing is this security and high bandwidth communication. These are the requirements from the strategic sector today. And the hand-holding, today the hand-holding of industry, academia, regulatory bodies like NCIL and all, and government organizations, etc., will definitely empower the defense sector by boosting the meshed intelligence. So now let us hear from our friends in the esteemed panel members on how we are equipped for this particular purpose, for the meshed intelligence. Thank you all. And I would like to mention each panelist can take maybe some 7 to 8 minutes, and we can have few questions, and that way we can continue. So that we have 1 hour. We have almost 1 hour of time, and we can take few questions from the audience also. So we have, I think I should introduce the panelists. We have Mr. Suyash Singh, CEO, Galaxeye Space. Yeah. Mr. Akash, Yalagach, CTO, KaleidEO. Yeah. Mr. Kannan, Kesavapillai, co-founder and CEO, Augsense Labs. Then Mr. Gurvinder Chohan, CEO and founder, QSTC. And Mr. Damodaran Raman, Director, Deloitte Consulting. So, the few advisory guidelines, what was told by the organizers is, we have to stick to the timeline, maybe 7 to 8 minutes we can have maximum, and 1 or 2 few questions from the audience. Then another thing is, I request the panelists that let us not use anyway, we are not doing any PowerPoint presentation. That was another guideline what was told. Let us not have a PPT presentation, so that we will have more interactive discussions. Then these are the 2 things. So I request Mr. Suyash Singh to briefly share your background, expertise, and a brief overview of your perspective on the topic. Mr. Suyash Singh, please.
Am I audible? Yeah,
Yes.
perfect. Hey, good morning, everyone. I am Suyash, co-founder and CEO at Galaxeye Space. First of all, thanks for inviting me to the CR team, and thank you so much for the very lovely introduction, ma'am, and setting the context. So maybe as we have 7 minutes, I think we have a lot to tell on the exhibition booth, but I'll take you through what we do in next couple of minutes, and followed by any questions you might have. Happy to take it right away as well. So yeah, in a nutshell, Galaxeye is an image intelligence company. What we are trying to do is come up with a satellite that hosts miniaturized SAR and EO on the same platform, which means at the end of the day, the value add to anyone who is using our satellite or the data is we are making users' life easy by making SAR intuitive. So one of the problems that we encountered while evangelizing, brainstorming around what kind of satellite we should build, or many other things that we were doing back in 2021, was we understood that optical, which is really understandable by any user, consumable by any user, is not always available, which makes life harder at times to get any information out of it. So then we naturally move to something like synthetic aperture radar imagery to solve further problems that we have. When we go to SAR, at times, the understandability is not as much there, which is in the optical imagery. So we thought, if we were to make SAR intuitive, like optical, what can we do? And that is where Galaxeye was born. We thought if we can put together a SAR and a EO sensor together on the same platform and do a concurrent imaging, which is spatially matched, temporally matched data set, and deploy a bunch of deep learning models on top of it to recreate an optical for any SAR collected. Let me give you an example. Let's take a scenario where there are 10 trucks standing on a road today, and you have a clear shot from optical and SAR, and you have both. So that is a great scenario because you don't have any clouds. You are not doing in the nighttime imaging. So you have a clear shot of 10 trucks standing there, and you have something in SAR as well. At that time, you probably will not use SAR. You will only use optical. But let's say 2 days later, there were only 3 trucks standing, but it was very cloudy. Now you only have SAR. Now you have only 3 trucks, 3 signatures of the trucks. But then the life is harder to detect whether it's a truck or some other object or some spoofed objects. With our data set, we basically use a bunch of models which were trained earlier on the data set, which was collected on a non-cloudy day, and we make SAR available in a form of or closer to an optical imagery. So that is where we started off thinking this, and we have evangelized a satellite which can do a sub-meter level of imaging, which is very much required for multiple users. And we want to really bring down the cost of image acquisition. Right? So if you do it today, you'll put, let's say, n number of optical satellites, and you will put n number of SAR satellites in the orbit, which is also costlier, which is also operations heavy. Right? We want to merge them both, and using advanced technologies like deep learning, which ma'am was also mentioning, we are bringing down the same capacity and capability in a much lesser cost. So that is where Galaxeye comes in. We've also done multiple tests. We are not just saying that we will do this. We've already done data collection on prototypes level through different mediums, right? So we've done aerial testing for tactical surveillance. we are now going to launch the satellite for the strategic surveillance as well. Now, concluding, right, the three dimensions of resolutions that we want to capture generally in a satellite imagery context: spatial, temporal, and spectral. Ideally, we want to be the best in all of those three, but you may not be able to do that because of the limitations of the physics. So spatially, you can go up to sub-meter resolution. Spectrally, you may want to go hyperspectral, but the resolutions will be limited, cannot be more than 5 meter or 10 meter. Temporally, you need a bunch of more and more satellites. With the combination of EO and SAR, we will be optimizing on this 3D space of spatial, temporal, and spectral resolution map and give meaningful outcomes to the users. So this is, in a nutshell, what we do at Galaxeye, right? And of course, our satellites is work in progress, will be launched very soon, by the end of this year, possibly, right? Or early next year, whenever we get the launch slot from our own country. So that's where we are. Happy to answer any questions you might have on this, and also, take up any questions you had. Yeah.
I'm Naresh, I'm from CSDR. So my question is, at the start of Galaxeye, there were different demands for different types of sets of data from commercial point of view. Like there was a type of demand from hyperspectral, SAR, and other types of spectral data. So how did you manage the trade-off and ended up choosing EO and SAR as your value proposition? And so that's my first question. And as the industry has matured in the past 3 to 4 years, how did you plan to compete with other types of startups in terms of data sets, if that makes any sense?
I think at large, right, if you see, I'll take the competition bit maybe first. At large, if you see the competition, if you compare one kind of sensor to the other, that's not an apple-to-apple comparison, right? See, this is not a competition for that matter, by the way. This is a capacity building, and there's a capacity gap for a kind of data set which is not available. Right? So I don't see at large anyone is competing in this ecosystem for the same sensor, or rather they are more or less collaborating. But what I see is there's a gap in acquiring a particular kind of data set, which is EO plus SAR, because of some of the challenges in the technology innovation, which we have cracked at Galaxeye, right? So that data set, of course, is very useful. Now, coming back to your first question, why did we think of EO plus SAR? Right, so we were dealing with a forest fire problem in the beginning, and we took some optical images. It was all smoky, could not see through it. So we thought, maybe we can take SAR and get some more understanding out of it. We took SAR. It was all grayscale image. And that time I was not an expert of SAR, so it was I had to do a PhD to really understand what it is. And so could not really understand it. So thought, if we can merge these two together, what can be the outcome? We did that. In a forest fire use case, it made sense. For a coarser resolution, you can still do an EO plus SAR, because it doesn't matter that are you looking at a sub-meter resolution object or not. And temporal resolution also doesn't matter a lot in those use cases, right?
So, sorry to interfere, Suyash. Can we reserve our questions towards the end of the session, because we have 4 more panelists.
Sure.
I myself have few questions, but we will have the discussion towards the end of the session.
Yeah, but having said that, that data fusion on Corsair was not as much, as a problem, but on a finer data set, it looked like a problem, and that's where we started. Perfect. Thank you so much.
Yeah. Thank you, Suyash. Now, may I request Mr. Akash Yalagach, CTO, KaleidEO, to give his thoughts in this topic.
Good morning, everyone. And thanks, Radha ma'am, for the introduction and setting up the context for this panel. To introduce myself, I am Akash. I'm the Chief Technology Officer at KaleidEO. And at KaleidEO, what we are working on is bridging the gap between the upstream sector of the Earth observation to the downstream sector of the Earth observation. And we have emerged from a company called SatSure, which is our parent company, and SatSure has been there since 6 years, processing Earth observation data specifically focused on civilian applications, starting with agricultural applications to understand what is the risk involved when it comes to lending money to a particular area of farmers or farmer produce organizations, and helping banks in taking quick decisions in disbursement of the loans, and that led to financial inclusion of the farmers as well. And then over the time, we moved on to understand applications for monitoring infrastructure. And when we talk about any built-up features, a built-up feature is nothing but a man-made feature like building, bridges, like oil and gas facilities, etc. Right? There we need high-resolution data, and that is where we discovered challenges of procuring and using high-resolution multispectral data by sitting in India, like by being a company based out of India. And that is then when we thought that, okay, like for our own business case, we should have our own source of high-resolution data. That is how the thinking started, and that is how KaleidEO was born. And we are working on a high-resolution, high-swath multispectral Earth observation imager. So we are talking about 1 meter GSD class, raw GSD, I would say, class imager, and with a swath or a field of view, we can cover around 65 kilometers, because traditionally, most of the high resolution imagers have limited swath based on the design, the way they are actually designed, and that is an innovation that we are bringing in. So with a very wide swath, we can cover large area. So we are looking at covering 1 million square kilometer of area every day with just 4 satellites. And also it will help us getting a revisit or visiting the same point on Earth at any given point of time, around 1.5 to 2 days on any point on Earth with just 4 satellites. And that helped us in getting the cost per bit of data that we generate on the satellite to get it down like at a very economical cost point of view. The second is we also have or planning to have edge processing, like what Radha ma'am was talking about, to enable onboard data processing on the satellite. This onboard data processing will help us in increasing the value of every bit that is actually generated and how we downlink the data itself. And in fact, we demonstrated the edge processing last year in September with a third-party satellite and a sensor, where we were able to detect road network on the satellite itself. So like, to put a context, it's like we are looking at an area, say at multiple regions, where we downlink the data, we process, and then understand, okay, like there are certain features which are coming up over the time. So how do we get this turnaround time shorter, like so that we can make decisions quicker, right? So that is where edge processing or onboard data processing comes into picture. And coming from a downstream EO sector, like we understand the challenges and issues in processing multiple sets of data. So be it aerial, be it like from the satellite Earth observation data, and also we have worked with data sets from drones, right? And combining these data sets together and deriving information, which is what the topic of this panel is, right? And that is something which we have realized the challenges, I think, sometime in 21, 22. And over the last 1 year, we have built a data processing pipeline where we are looking to ingest data from multiple data sets, like drones plus aerial and plus satellite Earth observation. I would say we are very early stage in combining data with SAR as well, which Suyash has talked about. And yes, like he mentioned, it is challenging. And that is something which we are also looking to work with. And yeah, like just to put things in perspective, wanted to talk about how data sets from different sources can be combined together, and what are the challenges and how it leads to, say, efficient decision making at different levels of an organization, be it military or even civilian organizations, right? The recent conflicts that are going on across the world due to proliferation of civilian Earth observation data, anyone can go ahead and order data which is slightly lower resolution, or in case like even higher resolution of around 1 meter or less than 1 meter, you can go ahead and order, which is expensive, and do your own analysis, and which is what many of the military bloggers have been doing since last 1.5, 2 years. And we have seen combining such civilian analysis data sets into institutional data analytics. Basically, it is meshing of civilian data set into strategic data sets and having to take decisions. In fact, I think it was one of the countries who used NASA's Landsat plus MODIS data set, which are very low resolution. Landsat is of 30 meters GST, and MODIS satellite is something of around 200 meters, if I remember correctly, which is a part of their forest information resource management system. They have tried to use that civilian data set to understand where the artillery usage is happening across their territory or across the enemy's territory. So as we civilian satellite operators start operating, there is inadvertently, definitely there is, we will be venturing into a space of strategic use cases as well. And these satellites can definitely help in making or building solutions for strategic use cases. And as a processing company, yes, like we go down to starting from, say, data capture, processing the data chain, and bringing out analytics so that decision makers can take their decisions efficiently. So yeah, thank you.
Thank you. Now let us hear from Mr. Kannan Kesavapillai, co-founder and CEO of Augsense Labs, to brief his views.
Thank you, Chair. Hello, thanks for SIA for giving this opportunity to introduce myself and my organization. I'm Kannan, co-founder of Augsense Lab. Probably we are one of the very early stage startup here. Augsense Lab started with a philosophy of any sensor output is just a tip of the iceberg. We can still squeeze out 90% of untapped information using computational sensing. So we started as a computational sensing startup. We were taking expertise people from medical imaging, etc., how to build our sensing solution. When it comes to meshed intelligence, Suyash and the chair talked about multi-sensor payload. We were considering going one level down. As Lieutenant General Pannu mentioned in the inaugural session, we are seeing an overload of need of sensors and need of more sensing data. So we started our journey of building an RF sensor which can act as multiple modality. Can a single RF sensor can meet the sensing need for surveillance, atmospheric profilings, pollution monitoring, etc. So in this way, if we are able to achieve that, we will be able to reduce the need of different missions, say for example, radio occultation missions and RF missions can be combined. So you can have multiple missions at the same cost. And second problem which we consider is when it comes to surveillance, relying on active radar. during a peacetime everything will work, but during a wartime you cannot have active radars surveilling on an enemy territory. It will give a reason for anti-satellite technologies to kill our satellites, kill our HAPs or drones, etc. So we decided that we wanted to create a sensor can collect more data passively. Can a passive reservation of RF which lead to passive SAR, which lead to radiometer, etc., which can be giving data, same time data to the defense and to the industry also. But in this particular context, one of the limiting factor where we were struggling is how to capture the weaker signal, because until your algorithms, you can come up with innovative algorithms, but to work with innovative algorithms, you need to capture weaker signal. So we in Augsense Lab, what we are trying to do right now is, we are building a quantum enhanced RF receiver, which can scale at multiple levels, drones to HAPS to satellite, and which can sense weaker signals. So we believe that once our sensor is completed, we will be able to create modalities which we have not even thought about it, or which we can collect passively the intelligence, same time give atmospheric profiling information to the industry and dual usage. So to create, so this is one of the opportunity we are working on that. To sustain this, we might need to not only as any satellite, we are playing only in the sensor level, we are not a satellite company as such. We should be able to create satellite solution which will same time cater the need of the defense and to the industry. So probably one of the challenge with the existing satellite companies and the defense is how to exchange the data. Probably this is one of the area where the defense think tanks also need to work on it, how the exchange of the data from a defense satellite to industry has to work. We should have an agreement of level 0 data can be given only to the defense, but level 1, 2, 3 data can be given to public. So if we create that kind of a mechanism, then we will have the economical advantage to create more satellites, more HAPS, more drones, and same time we can limit our cost. This is our initial thought. We can catch up anything on any specific point. Thank you.
May I request Mr. Gurvinder Chohan to share his thoughts?
Good morning. My name is Gurvinder, and I've been listening to since morning these conversations, what's going on, and discussion, and a couple of points are very intriguing where we are heading. And I heard all the comments made by all my colleagues here. What we are talking here is so far downstream. What I'm going to talk about specifically focus only on defense spectrum. What we do, defense, theater, warfare centric. Unfortunately, I had a very nice slides to show exactly what we are doing, but organizer decided not to show any, and sometimes one slide is worth 1,000 of words. But I try to give you a visualization what we are doing. So QSTC is about 10-year-old company, and the name stands for Quantum Scientific Technology. So originally when we started, the whole idea was to come up with a quantum-based technology to fusion and develop some new technologies to replace RF technology, optical technologies, and laser communication systems. Then we gradually grew, and now in some short span of the last 4 or 5 years, we are proud to say that we are the first company in the world to have a smallest geo satellite in orbit. It's only 16U and can provide you multi-platforms in which we have SDA, 2 telescopes, 2 cameras, 14 megapixel and 5 megapixel cameras, and you can take pictures of any asset in orbit, number one. Number two, you have a RF sniffer. So you do sniffing and look at what's going on, RF spectrum monitoring. Number three, you have a communication payload. all in 116U and 40 kilogram satellite. We are launching 2 satellites next year for undisclosed customer for space domain awareness, similar type of platforms. We are developing a complete constellation of electro-optical SAR constellations. Now we are going to come, when I see here multi-sensor payload, in my opinion, multi-sensor, when you talk multi-sensor, I believe all the assets what you have on ground. For example, you have a radar, you have other telescopes, you have other intelligent information on the ground. This is how you fuse with your space assets. And then you go to the command control center, and then you have a full visibility of your whole theater. This is what I call a multi-sensor payload fusion and integration. And right now we are doing one program for a particular nation, and this is like a 7-year program. By 2031, we will have a central nodal theater where all forces, all assets will be integrated into one joint theater room where you can have access to everything what's going on in the whole country. So they are integrating all the gateways, all the remote sensing satellites. They are all coastal surveillance radars. They are coastal surveillance ships. The fighter aircraft, either it could be fixed wing or rotary wing or UAVs, anything, all connected, and they get all assets. We did one presentation. I had another slide which was showing with this fully integrated asset, the time you locate a what you call dark vessel, till the time you locate a dark vessel and you send your Coast Guard to there, it was 45 minutes. The whole operation took 45 minutes to identify, send the mission, and to locate it. So you can see, and as mentioned, Madam mentioned, that information at the right time, that's critical for any time. Keeping in view that, so what we did, we came up with a solution of edge computing and onboard processing based on artificial intelligence and machine learning. What it does, again, I had a very nice slide, sorry, I can't show. When it takes an image, it does processing on board on satellite. So you don't need to wait for the ground stations to do processing or imaging. We did a demo, we did a prototype, and you can have right away on your laptops the JPEG image. So you don't get TMZ and all those multi-terabit files. So you get right away the end results. And on top of it, we have a machine learning and artificial intelligence. It does an analytical itself. Let's say 2 days ago, we had a picture taken and there was nothing. And after 2 days, we suddenly noticed that there is a base camp. So this will do automatically analysis and flag it to you. Hey, there was something changed. Similarly, from the Air Force, if there is a airfield anywhere, and you can see that there are some 7 runways, there are 6 aircrafts, and 2 are gone. So you know the 2 sorties are going on somewhere, and the 5 are here, or somewhere is going on. So this type of intelligence we are talking about, and the time is critical. And this is what we are working on. When we talk rapidly deployment payload, so we are demonstrating technology this year in fall. Our mission is IM-2 mission with NASA under Artemis, where we are sending the world's first OTV, orbit transfer vehicle, which will go to the lunar orbit and bring back the satellite all the way to GEO. So this way we are going to demonstrate rapidly deployable payloads so that you can have a launcher which is LEO and can take your satellite to GEO up to the lunar orbit. No problem. You don't need to wait for a GEO launches or GTO launches, which are very expensive, plus you have to wait forever to get a GEO launch. LEO launches are more frequent and easily available from all across the platforms. So these are the spectrum which we are talking about. I won't take long time, and I'm here if you want to have a discussion and if you want to have more in-depth discussion, because this is a very vast subject and it cannot be covered in 6-7 minutes. So I can talk on for a whole day if you want. But if you have more discussion, I'm happy to answer your any question. Thank you.
Thank you. Now let us hear from the next panelist, Mr. Damodaran Raman.
Good afternoon, all. I could see the deep silence because I know that it's 12 o'clock, close to lunch. And so the order of speaking, I was just wondering that there are experts from the startups which have got their specific products to talk about. So I am from Deloitte. What I'm going to talk, right? Either I should set the context at the beginning, or I should give something at the end of the conversation. I think by default it has come at the end. So let me introduce myself. My name is Damodaran Raman. I started my career as a space scientist, the first batch of cryogenic in India, and served ISRO for 14 years. Then I moved to a multinational company which worked into the microservices, cloud, and whatnot into the data. And I was a CTO and then 3-4 companies. Currently I'm with Deloitte. Now why I mentioned my experience, because when we look into the topic of meshed intelligence, right, and we talk about multi-sensor payloads and analytical platforms, if I really look into the each and every word, it's a PhD subject, isn't it? So that's the depth. And I have opportunity to just work on space, and I also work on the data and the applications and all the aspects, right? So currently looking at the audience, and this conference is concerned, first of all, what is meshed intelligence, right? So basically it's the collection of data from the various data source, digest, very, very important. It's all easy to say. When you get the data from the different ones, and then making the data consolidation, which is making a meaningful insight out of that, is not that easy. Currently, you have a lot of AI ML models which has come in, which has curated the data into the different data sets, and you have the algorithm to do that, right? Currently, when we started in 91, 92 time frame, these technologies were very, very primitive, and it will be very difficult. It's a lot of manual, laborious task. I think today the technology is advanced so that we can get the insights from there. And you could see the data lake, data mart, data warehouse, which you would have talked about, right? Irrespective of defense or the commercial, the source of data from the different sources, which you could able to put into a platform, and how to get the relevant insights out of that. The insight has now matured to the actionable. So as a Deloitte, I think we have started our space sector a year ago, and pretty much we are trying to help the community with what is today's the need in this particular sector. So we also published a couple of thought leadership paper, particularly on predominantly on the downstream data, because that's when we see that large potential for the startups and things like that, along with NASCOM, ISPA, and CII. So when we talk about why the meshed intelligence is important at this point in time, is basically space is concerned enhanced Earth observation, because when you have the data from the different sources, I think the quality of the data which you get on the Earth observation will be more clear, and you can make the decision making faster. When you talk about the defense, it's basically a situational awareness, right? Basically, I think the more the data, precise data, and data is processed in the right way, you will also get early warning threats, improved targeting, all those aspects. So that's an advantage. More or less, if you ask, the meshed intelligence is the need of the hour today, right? Because if you are not gearing up, I think the competitor will really surpass us. So when, as a tech guy, I could see that what are the key technology enablers towards this, right? Today you see that advanced payload technologies, which all our panelists, which they talked about, everybody is working on the very niche area about RF sensors, right? Somebody's talked about how to make optical and SAR together in the same platform. I think it's going in good space. So that's also enabling a meshed intelligence to the next level. And second is data fusion and integration, which we talked about in the length, because currently the opportunity is very good. Earlier time, the biggest issue was the storage of the data. These are all the high volume data. Thanks to cloud, which has come in, and the cloud services. When we talk about now, you have an edge location, you can get the data in any time, in any moment, right? So similar way. So the data integration and the data fusion is going to be the key. I think the lot of work has been done. I think we have also got good maturity into that area. The third one is about AI and ML. Basically, these are all the key technical enablers which I'm talking about. Artificial intelligence to the machine learning, now machine learning to the now LLMs, large language model, and then getting into the quantum now. So that is the path which is going in. You have lot of models, but your pattern recognition, your lot more use cases which you can do, which is readily available. And most of these things are open source. If you have the right data set, I think you can get the insight out of that. Edge AI applications, which panelists have talked about, it's going to be very crucial because the just in time, the time you are getting from a signal from X distance to Y and get into the ground station and then process it and then getting into, I think we don't have the luxury of that much time, right? So the design of those onboard computers in designed in such a way that can we process the end-to-end in the onboard and get the end results. I think that's what it is, the new things are getting into. Communication technologies also, today if you see the satellites, because high throughput communications, right? Because satellites assets has to communicate between each other and then it also into the ground station. So that's also enabling meshed intelligence to the next level. Multi-payload spacecraft, I think panelists have talked about. I think now any spacecraft will take multiple payloads, which will really enable us to get the different aspects of the data in the ground for the processing. When we talk about the data, everything, cybersecurity is going to be the key one, right? Particularly when we talk about, I think, cybersecurity solutions in any data transfer. I think that's an evolving process. I think it is a continuous process. That's an area. I think that there are a lot of focus which is happening across the globe, and that's going to be a very, very critical one. And quantum key distributions. Basically, I think as you know that in the software industry, when we want to, when you make an HTTPS, URL, I think the security perspective, I think we have a proxy server, we create the JWT token and all those things, right? So those things are becoming vulnerable right now, right? So that's when I think even those securities, can we use the quantum key so that your security becomes very, very stringent, right? So that's what. Satellites miniaturization and unmanned vehicles. See, miniaturization of satellites, I think as my friends talked about, I think the CubeSats, microsats are really emerging. And as somebody was mentioning about in the LEO orbit and then using the drone and all those things, I think the capability of getting the observatory data is becoming huge. Hence, the meshed intelligence is becoming very critical. And finally, the IoT and sensor networks, right? Pretty much, I think we need to really look into these data, which can be IoT enabled so that it reaches the destination then and there. So these are all the few 7 to 8 key technology advancement which is happening, which will really make the meshed intelligence to the next level. Quickly, I'll take a minute and close my things. So what are the key drivers? You can ask the question, why we need to go for so much of technology, so many, around 10 parameters which I talked about, because this is the need of the hour for us to do that. The reason being, so geopolitical tensions are becoming, day by day it's increasing. I think the technology is going up now. The space is the fourth warfare. That's what they talk about, right? In future, everything is all to be in the data, right? So one has to be upfront in this game. To be ahead of the geopolitical tensions. Second thing, modernization drive. I think even particularly even in India, I think all our armed forces, defense and civilian, everything, I think we want to get into the modernization, from the legacy to modernization. See, that's also a driver for us to think of all these directions to get into the meshed intelligence. And technological advancement we talked about, I think we are into the good era of achieving all those things. And Atmanirbhar Bharat initiative, right? At the end of the day, as Prime Minister talked about, I think self-reliant. And we as a Deloitte is also working few of these things to, how to take this journey to the next. Still, we are not there. I think even when we talk about all these things, I think particularly if you talk about the satellite, 55% of the components, still we are depending on the outside nations, right? So how you can become the self-reliant? When we talk about the security perspective, this becomes the very crucial part. If you don't have those component per se. So with that, I could see that the meshed intelligence is going to be the need of the hour, and it's not a choice now. and then all the peripheral factors are well in place, and we should enable our working area to get the best out of that. Basically, the reusability and resilience and time to get the information. Thank you so much.
Thank you. So it was very interesting and insightful discussions we had, and I would say that all panelists could effectively showcase the industry's potential and the vital role of private sector in boosting India's defense space capabilities. So I think we can quickly go to a few questions before the session. If from audience, if anybody is having.
Can I give a here down? General Brarer, on the first row.
Okay.
You see, it's more of a comment and a suggestion because, you know, in everything which you do for intelligence, it has to finally result into an operational action. So therefore, the start point has to be the user or the people in uniform. They have to give you the concept and the framework. Because as far as defense is concerned, three things are not clear, whether in peace or definitely in war. What you are looking for will never be clear. Where you have to look for will also not be clear. And what you are looking for and type and the time will also not be clear. So, you know, everything is so dynamic. So this thing which you may have the best of the intelligence, best of the sensors, best of the satellites, this whole thing has to be actually meshed. And it is not intelligence because, you know, intelligence is when all the information is collated at a place. Intelligence would be, let's say the X country is about to launch a war. That is intelligence. So what will come from you would be information. So I was happy to hear Mr. Chohan, the framework on which he's working would be something, it has to be beginning to end. But then notwithstanding all the companies which are making something, they have to fit into the mosaic, you know. So this mosaic has to be linked in to a concept, and that concept has to be driven by the user. So in fact, I am saying myself, that unless the user is involved, the companies will not know where to go.
Yeah, very right. Yeah.
May I make a comment on this? So, sir, absolutely right. Just to give you an idea how it has worked in our part of the world, like for SDA, for example, or US Air Force. So normally they are the one driven, like as you said, user driven, number one. Number two, right now the SDA, they are coming up with the universal policy. That means all the interfaces from the radar or all the sensors, they will be universal so that they can be part of the big mosaic. You can just plug like a Lego. So that's what they're working on, like bringing all these things into one piece, into one comprehensive Lego piece, where you can take any piece, plug and play. And then the whole mesh will work. This is already a concept. About 80 to 90% the specification and the requirements are set by, as you said rightly, by the user. Exactly. So they are the one who define, hey, this is what I want. So make sure you have the equipment which meets all the specifications and plug into play into each complete mosaic. So this is what's already happening, and this is what we are doing right now. So that is possible by 2031 only. That's what I said. This is a long roadway to go, but this concept is same what you just mentioned.
Tomorrow we have a session dedicated to mosaic warfare. Meshed intelligence is, of course, getting all the inputs together on a platform, and the process of decision making has to be pre-fed. And on a larger platforms, it becomes impossible, as General Brad was saying, what to do, where to do, how much to do, with what to do. But once you make a kill web, that we are going to talk about this concept tomorrow, I think largely the industry will understand how this entire mosaic can get activated through automated decision. So I think it's very interesting that we are already building a foundation for that.
The only thing which I don't feel comfortable, to be honest, is the automatic decision making. We are not there yet. We can dream about it, we can talk about it, we can debate about it, but we are not there yet. It's a far-fetched dream to have an automatic decision making. We can make a logic, we can have algorithms, we can do any analysis, and we can ask a recommendation that yes, this is a recommendation from platform. But end of the day, our human mind, or the people who are making the decision, they should be the one making the decision end of the day.
I'm glad you raised this. That is exactly what we're going to be talking about tomorrow, that how is it going to be possible to put decision making into the process. Otherwise, network centricity and system of systems are taking you much away from possibility. But making a kill web will bring you nearer this possibility. And we're going to talk about it tomorrow.
Good afternoon. I'm Commodore Shergill. I'll buttress whatever General Pannu and General Brar have brought out. Integration is indeed a very weak area in every sphere of life. I am very happy to hear that you are doing something, you are taking baby steps, and it should fructify in future. And you would have done a big job insofar as integration and fusion is concerned. I just wanted to ask one question. Are your systems catering for hardening also against cyber threats? Because that is also very important. And one more observation I had, somebody in the panel said whole of nation approach is required. That is an understatement. It is not only whole of nation, it is whole of nation plus friendly foreign countries also. Because space diplomacy is very important. International cooperation is very important because space is a global domain. Thank you.
So I will answer 1 and 2. Number 1, the hardening. I think with respect to the hardening, there are a couple of things which you have to keep in mind. As I think it was mentioned by my colleague as well about the cyber security. And then we have other thing, we have EMPs. Not only just the cyber security, but you have to take into consideration radiation and nuclear fusions, and now there is missiles in space. Not disclosed, but we all know it's there. And then you have other threats. So that's why it becomes important. You have multiple platforms. One, for example, what we call space domain awareness. You should be aware of all the people who are in the space in your neighborhood. What is their composition? What type of satellite they have? What is their capability? Like if you look at the satellite, we can tell easily like what type of composition it has, what type of antennas it has, what's inside it. We can do that analysis very easily based on the tools what we have today. That's number 1. Number 2, you can also introduce. Right now we are working with two programs. One we call as a QKD. With 26, I think there's a launch of satellite, first satellite, official first satellite, built by Honeywell, and we are part of that. So that's a QKD demonstration, and we are doing some nuclear watch, this and that, to do that algorithm. And then we have one we call rehop, dehop transponders. And that's the trick. It's just a lower level than QKD, but it serves the purpose that your satellite becomes a fully encrypted, that nobody can come nearby to get the information what you're seeking or doing it. Right now, as far as I know, officially, there are only 3 countries in the world that have this capability, the rehop transponder systems. And the second question you had a second part, the internationalization. So absolutely right. So the program we are working is a part of the I5. 5 Eyes what you call. So 5 Eyes are all part of this. So once you implement, so all 5 Eyes can look into this one.
Ma'am, good afternoon. Ma'am, one question. This side. Admiral Bansal from IIT Madras.
May I request to reserve for during the networking lunch, because I heard from the organizers that we should wind up now. And anyway, many are having questions. So can we reserve it, or okay, quickly we'll take one more question. Yeah.
Probably it'll give food for thought during the networking lunch. So ma'am, quickly taking you back to the mid-80s when the Cold War was at its peak, if you recollect, the President Reagan had come up with this strategic defense initiative, that is Star Wars program. So my question is to General Pannu and the startups here. At that time, so much of research had gone in, billions of dollars had been pumped in by the USA and by the USSR as well. That time it was still intact. Are we making use of the lessons learned then? Is that research come in handy, or it's just gone waste and we are reinventing the wheel? Just a quick question. Thank you.
We can spend hours and hours on this one. Let's have an offline discussion on this particular topic, because there's a lot of money spent, and at the same time, some money, yes, they set up the stage what we are today. It's not like we came out of nowhere. The money which was set aside at that time for R&D purposes or whatever the initiative they took, that's what we are seeing the result today. And you can see the result, like the baseline is still the same. If you look at the core baseline, it's still the same.
I'm eager to know how about the funding for some long-term R&D like quantum and all, whether startup companies are the funding process, is there any problem in that?
Yes and no.
aspect?
Yes and no. Something like a QKD type, yes. There is an initiative from the government or space agencies, they do a funding. And there are some programs where you take initiative looking into view of your business model. Like, yes, this is the future, this is we need to invest. And so we like to invest in that particular area. So then we set aside 2.6% of our budget to R&D.
Okay.
So this is how it works.
Okay. So I think it is time to conclude now. We had a very interesting discussion, and we were talking about upstream and downstream capabilities of the potential of industry and capabilities. And I think geospatial technology, as we are all, not only geospatial, entire this meshed intelligence is fast growing, and we are now talking about the spatial knowledge. Instead of spatial knowledge, infrastructure. This is what we were talking since quite some time, and whereas now we are talking about the knowledge infrastructure. So data has to be converted into knowledge, and knowledge has to go to the actionable intelligence. That is the need of the day. So I think let us conclude this discussion with the thought-provoking question, whether are we ready, are we equipped to take up this challenge today? Thank you very much. Thank you for listening. And we'll continue the discussion during the lunch break. Thank you.
Thank you to the esteemed moderator, and thanks to the esteemed panelists. Thank you for making a very animated and lively discussion. With that, ladies and gentlemen, we conclude this session, which was the panel discussion, Meshed Intelligence, Multi-Sensor Payloads and Analytical Platforms. We are now going to take a break for lunch, but please do note the timing. We are going to start the next session sharp at 13:55 hours, so please do make sure that you're seated well in time. Thank you and enjoy the break.